Okay, so our final section on data displays, this chapter 11, is about scatter plots and line graphs. So we will pull this into two parts. This first part is very straightforward and not tough, okay? A scatter plot. Does anyone have any idea what that means? Scatter plot. Hannah? It's a graph, good. That's right. It's a coordinate plane, and then there's a bunch of points on it. That's what it is, okay? It's a graph of ordered pairs, which are points. So we end up with two values, and we can gather information in pairs. Like, for instance, I could say, how tall were you when you were born? And how tall were you at every birthday? And I would have your age paired with a height, right? And I could plot that. Who has seen that at your pediatrician's office? Did they ever give you one of those pages that shows that? No? My pediatrician for my kids gave us little tables. Ask your parents. And they show these little dots of your height as you're aging. And they show you how you compare to the national average, too. So are you really small? Are you really tall? You know, it's kind of fun to look at. When you're babies, they also do that with your head circumference. Isn't that interesting? Because they're looking for like normal growth. They want to make sure you're growing within the normal range. And if not, they might need to help you, you know? So interesting graph. Okay, we're going to make a scatter plot. Here is the data. It is from the guided practice in your book. Page 660, I think. Let's see. Yes, 660. So we're going to just make one of the two because I don't think that this is that challenging. Let's take down the data. Notice that we have C and D rather than X and Y. That's okay. On this coordinate plane that I've made, C is on the horizontal axis, D is on the Y, the vertical axis. The numbers are rather small, so I'm using the regular scale of each blue line represents 1 unit. And we simply graph the points. Okay, so don't forget to start at the point of origin. And for this first point, we're walking -2, flying -5. The second point, walking -1, flying -4. The third point, 0, walk 0, fly -3. And the last point, walk 1, fly -2. Walk before you fly. C comes before D. X comes before Y. Okay, so what do we have in front of us? A scatter plot. We don't need to do anything else. What are you tempted to do?
Draw a line.
Draw a line, but you don't draw a line. It is a scatter plot, so it should look like the stars in the sky. This is like a little linear constellation or something, okay? You just leave it alone. You don't need to draw the line. Now, there will be a time when we draw a line. And so you're asked to fit the best line to this. And that would be easy for this example, but you do not need to do this one, but I'm going to do it. So we can just see another one. So here we go. Walk 0, fly -2. Walk 3, fly -4. Walk 6, fly -6. Wow, this is looking linear too, isn't it? So there you have, different types of scatter plots. Okay, that's all you do when you're making a scatter plot. But then we're going to say, what is the relationship between the X and Y's? How are they related? The word is correlation. What is their correlation? So in the first one here, as the X's or as the C's increase, what happens to the D's? They are increasing. So if I was to put a little ant on this set of points and the ant was jumping, is the ant jumping positive or negative? Remember? Positive, that's right. Just like our linear equations earlier this year, we always read these things left to right. So let's go jot this down. Interpreting scatter plots. To interpret them, I want you to draw 3 quickie little scatter plots. Just do your quick little coordinate planes, X and Y. And on the first one, we have points, look at this, they're kind of getting greater y's as the x's are getting greater. See that? The second one is like the reverse of that. And then the third one, they're all over the place. Okay, so draw quick little sketches. And then we're going to talk about their correlation. Okay, so for this first graph, as the x's are increasing, the y's are increasing. So what type of correlation? In other words, if we were to describe it as positive or negative or none, what would it be? Positive. So just like a line, right? The ant is crawling up the line left to right, it's going up. It's a positive correlation. The relation between x and y here is positive. You can see the little word relation in the word correlation, right? As x's increase, y's increase. So I guess we can simply look at the second one and see that as x's are increased, what are the y's doing? Decreasing. So instead of a positive correlation, we have negative correlation, right? And in our final example, bless you, look at this is really random looking. As the x's increase, I don't know if I'm going to have a y value above or below the x-axis, right? So what kind of correlation? None. So as x's increase, y's are doing what? It's like a question mark. I don't know what it's going to do. It's very random. So we would say there's no correlation. So maybe when you're doing a science project next year, you will try something and you'll see that there's a relationship. Like the more you feed the fish, the fatter it gets. You know, here it is, right? Or the less you feed the fish, the skinnier it gets, right? Or the more you feed, it doesn't seem to affect the fish at all. It's just staying the same. Maybe it knows when to stop eating. I don't know. You know, it's interesting, okay? Okay, let's make a scatter plot of this data and then decide whether it has positive, negative, or no correlation. The only reason we're doing another one is I want you to be careful setting up your graph. You've always got to look at your points and say what needs to be visible, right? Look at the x values. They're really small, but the y values go anywhere from 3 to 20. So do you see that there's a different scale on the x-axis here than on the y-axis? So we always are thinking about the scales that we're using. Okay? Nick is asking, can you tell that it's positive, negative, or no correlation just looking at these points? Who can tell right now what it is? Positive. You can see it in the table. But if you're asked to if you're asked to make a scatter plot, then you do it. It's good practice. Okay? And you're right, this is going to show us positive correlation. Go ahead and plot the points. Don't forget your labels, x and y, and one number in each direction so we know what scale you're using. 0 is at 3. So I've got to keep track of my scale on the x is different than on the y, right? 1 is at 2, 4, 6. 2 is at 2, 4, 6, 8, 10, 12. 3 is at 2, 4, 6, 8, 10, 12, 14, and halfway, 15. And 4 is all the way up to 20. So there we can say positive correlation. Okay? Good. So that's all you need to do today. Not hard, is it?
No.
Isn't that nice? So when you're done, you're working on problem of the month. I'm going to give you 10 minutes for this, problem of the month, and you need to produce a status poster today. Check out the ones that were done by the other class.